Alright, so let's move on to this next problem. Where'd it go? We have another division problem. This time it's more challenging than the first one because in the denominator we have a binomial and we can't simplify the square root of 5 or the square root of 2. The technique that we use here is to multiply this fraction by the number 1 so it won't change the value of this fraction. It's going to look different. We see that a lot. We've got 1/2 and we sometimes will have to take 1/2 and multiply it by 3 divided by 3, and 1/2 is equal to 3/6. On the real number line, both of these can be represented as a decimal by 0.5. So that's the idea that we're doing here, is we're going to multiply by the number 1. Now we've got to be clever in how we multiply by the number 1. This problem is violating the rule that you can't have a radical in the denominator. So we use the idea of a conjugate. The conjugate of a binomial, you just come in and change the operation to make it the opposite. The opposite of adding is to subtract. So everything else stays the same. Don't forget the square root symbol around the 5. Change the addition to subtraction. Don't forget the square root of 2. Now, if I have a fraction that reduces to 1, the numerator and denominator need to cancel each other out. The numerator and denominator have to be the same. So now I'm ready to multiply these two fractions together. And multiplying fractions is not that bad because you multiply straight across in the denominator and you multiply straight across in the numerator. So in the numerator is going to be pretty easy because we just have a single term here. A single term might be referred to as a monomial. And it distributes. We take the 4 and multiply it times the square root of 5, and it distributes over the subtraction, and we multiply times the radical 2. So my numerator is 4 times radical 5. Don't forget the subtraction, and then 4 times radical 2. The denominator, I can't do it quite so quickly, and I suggest that whenever you have a binomial times a binomial, that you do it in the form of a table. So let's come down and write these terms on the side of a table. We've got 2 rows, so we draw a line across here. The second binomial, let's write it across the top of our table. So now we multiply the outside entries to fill out the table. And with conjugates, we're going to always see that a diagonal will cancel each other out. Let's see if we see that here. Square root of 5 times the square root of 5 is the square root of 25, or just 5. The square root of 5 times the negative square root of 2 is negative, well, 5 times 2 is 10, and we put that underneath a radical. Well, here, square root of 2 times the square root of 5, we can write that underneath a single radical. 2 times 5 is 10. And here, I have a positive number times a negative number. It's going to be negative, and radical 2 times a radical 2. Hey, the radical goes away. You have the square root of 4. Don't forget that minus sign. This positive square root 10 and negative square root 10 cancel each other out when I add them together. And when I add the 5 plus a negative 2, I just get 3. 5 minus 2 is 3. There's my final answer. I'm done. I claim that if you have 4 over the square root of 5 plus the square root of 2, that's the same as the fraction 4 times the square root of 5 minus 4 times the square root of 2, all divided by 3. So let's go check that on a calculator and see if we believe that I'm right here. I have 4 And then when I have more than one term, I need to put parentheses around it. So I have the square root of 5, and I have plus the square root of 2. Let's close that parenthesis. So let's get a decimal number for the left-hand side here, 1.095. Let's come over here and see if we get the same decimal number. So in the numerator, I need parentheses because that's a binomial. And divided by 3. So I should get the same decimal number unless I've made a silly mistake. Well, I get the same decimal number. Hey, my answer here I believe is correct.